Good morning, fellow programmers. Thanks for joining me. I'm T-Pine, and welcome to Let's Learn C++. Feel free to use the skip ahead feature on the right-hand side to jump to any specific sections or examples. Make sure to have annotations turned on so you can see what updates I make to these videos. Today I'll be using Visual Studio Community Edition, which you can download from visualstudio.com, or you can follow along with whichever IDE or text editor you like. Today's focus will be on enums and structs, which builds heavily on previous lessons, so check those out if you're unfamiliar with the topic. If this is your first programming language, I'd strongly recommend checking out my Let's Learn Python series, which teaches you the fundamentals of programming. All you need are the Basics and Object-Oriented Programming series, linked to the right, and you'll be well prepared for this C++ series. Alright, enum. What is an enum? Enum is actually short for enuma, otherwise pronounced enema, and that is the act of sucking water through a straw, through your butt. Okay, enough goofing around. Enum is, in C++, almost the simplest way for users to create their own type. Typediff is the easiest, but we're not going to cover that until much later. We're covering this in our first steps towards understanding C++ classes. Alright, so here we have our first enum example, and it's a pretty simple bit of code. First we have our IO stream, and then we begin by creating our first enum. So first we start off with the keyword enum to signify that we're going to be creating a new enum instance, and we're going to call this animals for our category. And then following that, we're going to have a whole bunch of items within it that are going to be its values. And something to note is that each of these items is actually separated out by a comma, not a semicolon. Instead, we end the declaration with a semicolon at the end of it. As we move forward, we're going to end structs, enums, and classes with a semicolon at the end. And this is important because if you don't put it there, then you're going to run into some serious problems. And then we're going to go ahead and create our second enum instance right here called groceries, and we're just going to put in eggs, ham, and milk. And this is to show you that you can list out both kinds of ways. C++ does not care about the spacing or line indenting that you do, so long as you have proper characters like commas or semicolons breaking them up. All right, and then we're going to go ahead and do a cout of dog, and then a cout of pig, cout of ham, and then to check, have a simple check of if dog is equal to ham, and the results may surprise you. Then below that, we're going to actually create a variable instance of a grocery and set it equal to ham. In the second, we're also going to set a variable instance of e equal to eggs. And this is to show you that you can set an enums value by either using the equal sign or using parentheses. Both work just fine. And then finally, we have a breakpoint here at our return 0 line. Okay, so if we run it, let's see what we get. Here, every single item within this enum, its values are actually being replaced by an integer. And we're starting from 0, so we're going to count up 1 with every single new item. So we're going to count from 0 to 1, 2, 3, and 4 for pig. And that's what we'll see right here. 0 for dog, and 4 for pig. And then we're creating a separate enum right here, and we're calling out ham. What is ham going to be? Ham is also 0. So these items within the enum, or values within the enum, are actually being replaced by an integer value. And so if we compare one enum to another, such as in this line 15, with dog equal to ham, it does indeed return true. This is a problem, however, like we wouldn't actually want to be able to compare two different sets of enums to each other. It doesn't seem right. We're going to address this issue in just a bit when we discuss enum classes. But for now, this is a great introduction to enums. Let's go ahead and close out this program. Values are being stored as a symbolic constant for enums, or basically just converted to an int. The C++ core guidelines, enum.5, says don't use all caps for enumerators. So all values within enums should instead be lowercase with regular variables, while enums themselves should have the first letter capitalized. So we see first letter capitalized for the actual enum name, and then the variables within it are all going to be lowercase. Remember that all caps names are reserved just for macros. All right, so how are enums useful? Anytime you have a list of things within a category, an enum could be useful. For instance, enum could be used for colors, error codes, or names of your recently deceased enemies, and really could be anything. So let's look at a second, longer example. First, we have an enum called whatever, and it just has a value of crap equal to a. What's going on in the background is this a is being converted to the integer value of 97. Then we have groceries down below, and we're going to start off our list at a value of 5. And then from there, every value following it is going to be set to the next value. So eggs is going to be set to 6. And then this one, milk, is actually going to be set equal to the previous enums value of crap, which is the A character, which is the integer value of 97. So it is possible to set enum values equal to other enum values if you so desire. Next, we have a function called grocery printer, and we're going to take in a parameter of groceries called G, and then we're going to have a switch statement and check to see which it is. My cat is chowing down on some food. That's what the crinkling in the background is. So after passing in that grocery, we're going to check to see if it's in the case of ham, eggs, milk, or a default value of nothing. So if it's ham, we're going to output it's ham. If it's eggs, we're going to output it's eggs. We're going to output you have milk if it's milk. And finally, you are very, very sad because the grocery you passed in can't be identified and you don't know what you have. Next, we have our main function, which actually creates an instance of ham, an instance of eggs, and then we pass in eggs to the grocery printer. And now if we run that, let's see what happens. Oh, forgot to set a breakpoint there. And now let's go ahead and run it. It says you have eggs. That indeed works. So we successfully identified eggs from being instantiated and then passed into a function and a switch statement, which printed out the statement of you have eggs. Awesome. It is recommended that you include enums, which we've seen here, in header files. This is because they take up almost no memory. Enum.6 in the C++ core guidelines says avoid unnamed enumerators. It is possible to create an unnamed enumerator, but don't do it. Don't do it. Finally, I want to look at one last tiny example. And first we're going to include the IO stream, which we always do. And then we're going to create an enum called clothes with variables shirt, cap, and dress. And then we're going to create an enum instance of pen, and it's going to be cap, body, and ink. This is the parts of a pen. And now, what do you think will happen if we output cap? Because cap is instanced in both clothes and pen. Which do you think you'll print out? The first one because it's stored in memory, or the second one? Well, the answer may surprise you. It's actually going to be neither. It's going to give you an error. This is a runtime error. And it says cap redefinition, previous definition was enumerator. And so because we're creating this twice, it's actually going to cause an error. So if we have multiple enums of the same name causing a runtime error, how do we get around this? Well, we get around this with enum classes. Enum classes are pretty much the same as regular enums, but they give a firm scope, thereby preventing the problem we just saw. So let's go ahead and paste in some more code. And here we have include IOStream, of course. Then we're creating an enum called non-class colors, and we're setting red equal to a hexadecimal value, which is going to be converted to an int, and then incrementing for that. And in hexadecimal value, this isn't actually red. I'm just going to note that right now. And then below that, we're actually going to create an enum class called class colors. And we're going to create red is equal to A, and then green is equal to the proper hexadecimal green value. And then blue is going to be equal to the proper blue hexadecimal value. However, there's actually going to be 255 here. And again, these are all going to be converted to ints. Next, we're declaring another enum called ASDF. Here we're following it by a colon, char, and then passing in a default value of C, and then incrementing to B1 and C1. Now, what's the point of this line, this colon with a char? That's actually declaring the enum type. However, being it's how it's going to be converted to an int anyways, there's not really much point. So finally, we're going to go ahead and output the red value. We're going to output the int class colors red value, and then we're going to output the B value. And let's see what happens. So we're saying that red is a value of 65,280. And that was the value we had up here, which indeed it is if we mouse over it. Then we have a value of 97 being passed out. And this is where we actually called red from the scope of our enum class called class colors. So again, the way that we access any one of these values within the enum class is we use the scope operator of colon, and then the variable that we want to access. And then I do a simple typecast of int so that we can actually output this value. Because otherwise it'd want to create an instance of it. And that's being output to -7, which indeed is the numeric value of a char for A converted to an integer. Then last we have B1 being output, which has a value of 68. Cool. And that is it. For enums, you just create the keyword enum and then the name of your enum instance. For enum classes, you just insert the keyword class in between enum and your enum name. Finally, I want to go through some C++ core guideline bullet points. Enum.1 says prefer enums over macros, and I want to say when it is applicable, because enums are always being converted to int values, while macros can store floats and character arrays. So this rule I'm like on the fence about. I'm not 100% sure about it. Enum.3 says prefer enum classes over plain classes. And this is because enum doesn't provide scope, but enum class does provide scope for the values you store within it. And this prevents you from accidentally overriding any previous values, any variables of the same name. Scope is a powerful thing, and you'll see in time that is highly valued. For now, just know that it means more typing. Lastly, enum.7 and enum.8 say specify the underlying type and values of the enumerators only when necessary. So only be specific and declare the enum type like we saw right here with the :char, and only specify the values like setting it equal to C or something like that when necessary. Otherwise, just leave it to the default value. And now I want to talk about Ascii. And this is going to sound weird, but bear with me. Ascii stands for the American Standard Code for Informational Interchange, or ASCII. It is 2 to the power 7, or 128 bits, large. It is used to represent all of the important keystrokes on your keyboard. If you're including the extended ASCII characters, it is 256 bits, or 2 to the power of 8, or 1 byte of data. So every character on your keyboard is being converted to some small integer value, which you can view, if you so choose, at ASCIItable.com. Highly recommend this when you're converting from a character to an int and vice versa. And you'll be able to see all the characters possible on your keyboard, as well as those that are extremely strange and useless. Mainly these ASCII keys down here. So most everything you'll see and read will be ASCII characters, just converted to different fonts, sizes, and whatnot. You can think of Notepad, TextEdit, or whatever your simplest text editor is on your machine. That is ASCII in its simplest form. And while ASCII is 256 characters, Unicode, which you'll hear quite a bit about in the future, Unicode is made up of over 128,000 characters, and it's only the first byte of data that is reserved for ASCII. So ASCII is being stored within Unicode, but not the other way around. You never know, you could have a interview question over that sometime. I bring this up now because what we saw with our enums was the computer converting the char character to an ASCII value. So the ASCII character of A was converted to its int value. Very cool. So now we have a little bit of an idea of what's going on. All right, let's move on to structs. Struct is referred to as an aggregate data type, or a way to package related variables together. Let's look at a struct in some code. All right, so here we have include IOStream, include string, and using namespace standard, of course. And then we have our first instance of a struct. And we just type struct, the name of the struct, which is cat, with a capital C. We always want to capitalize the first letter of all of our class instances, our structs, and our enums. Then we have a whole bunch of variables being declared line by line within struct. And again, just like with enumerators, if we so desired, we could actually put these all in the same line. However, just for readability, I would not encourage you to do that. Instead, this is much easier to digest for a programmer. Clean, it's easier to read, it's just better. Just do it this way, trust me. What's going on within this block of code is we have a declaration of an int called hair length, then a string called hair color, and then an int called fatness equal to 5. So the way that you set up a struct is you just declare the variables you want, and you can set default values for any instance of the struct, just like this, setting it equal to 5. Or if you so desire, you can also use the parentheses method. Then in our main block of code, we have a cat named Purple and a cat named Meowser. So weird. Why did I do that? Name it after my own cats? That's so strange. Those are my cat's names. So what's going on with these values? These values are being assigned based on the order of the variables declared within the struct. 8 is going to go to hair length. Then we have black and white, the string, going into hair color. And then we have fatness being set to a value of 5, which we didn't need to do, but I set it there anyways. Then we have an instance of Meowser, and right next to Meowser, you'll notice that we have the equal sign. This is not necessary, it's just there as a possible option or an extra key to hit. Perhaps you have some maniacal boss who says that you have to have equal signs there. Whatever, it works either way. I prefer the simpler, less keystrokey method, but it's really up to you. Then we're going to go ahead and output some of the data we've stored in these structs. So in purple, we're going to output his hair color. And then in Meowser, we're going to output the hair length. Important to note is just like in Python, we use the .accessor to access the variables stored within the class, or in this case, this struct. Very cool, very comforting to know that they're so similar. Then below that, we have purple.hairLength, and if we want to, again, change the value, we just access that variable, again, with the dot or period, and then the variable name, and then we can set it equal to some value. We can alternatively set a whole series of values all at once by using the curly braces to enclose all the values we're going to declare at once. So we have Meowser equal to a brand new cat. And something to note is this is exactly how my cat started out. It started out as a 3 in fatness, and then as time went on, it became a 7 in fatness. And her hair length did increase slightly. Hair color changed not at all. Finally, we have Meowser.hairLength, and we're outputting that value. And then we're ending our program. So let's see what the results are. Okay, now after combing all of that, I realized I did have a mistake in the code. There should be no equal sign equal to 5 right here of setting default fatness equal to some value. If you did want to do that and set some values by default, you could do that within a constructor and defining your own constructor here. Like we could do class there and then set fatness equal to 5 if we so desired. That would be one way we could get around it. But we don't want to do that just yet. In fact, we don't want to actually deal with constructors when dealing with structs. Instead, we'll save that for a later tutorial when we start getting into classes. So if we go ahead and run our code, we will see exactly what it spits out. For purple's hair color, it is black and white. For Meowser's hair length, it is 5. And then Meowser's hair length later, it is 6. So our code works great. And structs are really just a collection of public variables. I say that word public, meaning that anything or anyone can access this data and these guys as member variables. In the next tutorial, when we cover classes, we'll discuss the topic of public and private member functions and member variables. For now, just know that this is open to everybody, just like Python. Python has everything open to everybody, and as a result, you're kind of just hoping that people don't do certain things with your custom classes. And now I'd like to go over some things that you can do, but I wouldn't ever recommend. You can create an instance of a struct or enum after you declare it, but before the semicolon. But don't ever do this. C++ Core Guidelines C.7 says don't define a class or enum and declare a variable of its type in the same statement. Here, let me show you. All right, so we have a struct called blah, and we're creating an integer variable with a value of 5. And then we're creating an instance of this struct called avoid this, and we're not passing in any parameters. Now, again, you should avoid doing this, creating an instance of the struct or a class or enum after you have declared it, but before you have ended it with a semicolon. Instead, just separate it out into a separate line. It's super easy. Just do that. If you're going to declare an instance of the struct or class or whatever, just do it in a separate line. It's much easier to read. Rather, this placed here, it could be missed. It could be super confusing for somebody who's not familiar with your coding style. Another cool thing that you can do with structs and enums is nest them. And here I have a struct called cat, and then I have the hair length, hair color, fatness, just as before, and then I've inserted a struct within that called the ringworm, and the ringworm has an integer value of fatness. So my poor cat has a ringworm, and it's going to get fatter and fatter as time goes on, unless I deal with it. And then you can create an instance of that ringworm if you so desire by passing in a value for that first integer and then naming it, and I named it R. And then if I want to, I can put r.fatness to access that ringworm's fatness, and we will see, if I set a breakpoint right here, we will see that it does indeed output that value of 1. Cool. So you can create structs within structs if you so desire, or enums within enums, or any combination of those. Would never recommend it though, as it'll be tougher to navigate and it'll be unclear for the user. Instead, for now, consider namespaces as a solution to encapsulation and giving stuff scope. Something else worth noting is that you can create a function within a struct, but don't. That's what we're going to be using classes for generally. At least for right now, just don't create functions within structs. It'll make sense much later. The Core Guidelines C.8 says use class rather than struct if any member is non-public. Structs and enums can and should be created in header files for use across multiple files. This I strongly encourage. All right, and that is it. Thank you so much for watching. Great job keeping up. definitely try out these coding challenges shown here and the debug challenges linked below in the description. Leave me a comment below if this helped you at all, and also check out the comments if you're having any problems. Please share this tutorial with someone special and maybe support me on Patreon. Thank you so much for your support, and as always, like, subscribe, and keep the dream alive.